Exercise set 1.4. Applications. Two-variable linear systems of equations. Standards of solutions. Define all variables. Explain the source of any newly introduced equation. Assess the correctness of the solution by performing two types of checks: a check of the math problem solution and a check for sensibility in the real world. Of the two checks, the latter is the more important. Be reminded that the most likely source of error in an application problem lies in the translation from the real-world problem to the math model problem. Thus, the importance of a sensibility check. Calculator usage is required. Exercise 2. A business manager of a college ice rink is trying to determine the prices to charge for tickets to an upcoming hockey game. The rink has 250 Section A seats, which are close to the ice, and 600 Section B seats, which are more distant. Traditionally, a Section A ticket costs 35% more plus an additional $1.75 than a Section B ticket. The game will surely be a sellout, and the manager wants the receipts to total exactly $15,000. What should the price of the tickets be? Round to the nearest cent. All right, as far as some variable definition goes, maybe looking at this main question, what should the prices of the tickets be? This might be a good source of variable definitions. Perhaps we could let X equal the price of a Section A ticket. That'll be in dollars. And then Y will be the price of a Section B ticket, also in dollars. All right. Let's see, what have we got for information we want to incorporate here? This sentence here, a Section A ticket costs 35% more plus an additional $1.75 than Section B ticket. Okay, that'll surely have some sort of math translation to an equation here. Let's write this down. So we have the idea that a Section A ticket costs 35% more plus an additional $1.75 than a Section B ticket. Okay, let's see then. The ticket we want to make expensive is the Section A ticket. Alright, let's take its price. Its price is X. Now we need that to be not the same as a Section B, not equal to Y. It needs to be 35% more. Okay, so it would be 1 plus 0.35Y. Or put it together, 1.35Y. That gives us 35% more than Y. And now there's a plus an additional $1.75. So plus 1.75. Okay, well there's something. Call that our equation 1. Alright, let's look for something else that may serve as a source of equation. This sentence here, the receipts to total exactly $15,000. Alright. Total receipts is $15,000. Well, the total comes from two sources: the revenues from the Section A tickets and the revenues from Section B tickets. How we compute the receipts from just Section A tickets? Well, we're surely selling 250 of them. The price of each one is an X, so this would lead to 250X plus the receipts from those Section B tickets. The price of them is Y. There are going to be 600 of them. Multiply those two together. 600 tickets times Y price per ticket. Now there's our total receipts. It's to be 15,000. Okay, we've got something we can call an equation 2 here. You may look at this and say, oh, both sides divide by 10 immediately, very easily. Okay, 25x plus 60y equals 1,500. Then you may want to go further and divide both sides by 5 if you want. It's easy to do, perhaps. Why not? Okay, so then you could have 5x plus 12y equaling 300. Okay, we'll call this equation 2a. This system I use for numbering equations is that when an equation is first developed, it gets a fundamental number. Then if an equation is derived from a predecessor, it becomes an A or B or C thereafter. Okay. Now let's see. The math problem we have here, if we look at equation 1, equation 2a, each is a linear equation, two variables. Okay, so you don't have to write this down, but it's good to at least be thinking this kind of thought. Observe that equation 1 and equation 2a constitute a system of linear equations, two variable. Alright, and we are quite proficient at this kind of problem. I suppose we could solve this with our calculator very easily. And one of the advantages solving with a calculator has, no matter what, is that checking in the original equations is very fast and accurate on a calculator. So sometimes even when I see an easy manual solution, I still opt for a calculator due to the power of the fast checking of at least the math problem. So here, equation 1, solving for y, subtract 1.75 from both sides, and then divide both sides by 1.35, we could have y1 equaling 2 x minus 1.75 divided by 1.35. And then y sub 2 could equal, okay, working here off of equation 2a, subtract 5x from both sides, divide both sides by 12. Would give us 300 minus 5x divided by 12. And we are ready to go to the calculator. Okay, here at the calculator, go to the y equals 2 edit screen. For y1, we have parenthesis x minus 1.75 parenthesis and divide by 1.35. Okay, for our y2, we've got parenthesis 300 minus 5x parenthesis divide by 12. Alright, let's see, maybe we go to the window to get things set up for x. Now x is the price of a Section A ticket. We don't know much at all about the sensible range of x. I suppose one just kind of quickie guess would be to say that what if the whole stadium was just full of Section A tickets, and since there's 250 of them, and the total receipts is going to be $15,000. Let's see. Well, we know they can't be more than $100 because 250 times 100 is 25,000. That's too much revenue. So if we set X max to 100, that will surely be adequate to fit everything that we could possibly want to see here. So 0 for X min, 100 as a starting point for an X max, and let the calculator control the y-axis by doing zoom fit. Okay, we have got a single point intersection. Let's go calculate it. Second, calculate, intersect. Moving a little closer to the action before I start answering the questions. Is that our first curve, y1? Yes. Enter. Is that our second curve, y2? Yes. Enter. Guess. Calculator cursor comes over a little bit. About there. Enter. Alright. We have got this. Alright. Let's interpret this on our paper. Okay, so we've got a solution mathematically here. We've got this x equals to 22.72, and then we have a y equaling about 15.53, anticipating rounding to the nearest cent. Could round that there at this point. Now let's interpret this math, put it back into the real world. The X, we said that was going to be the price of the Section A ticket in dollars. Okay, so for our real conclusion here, we can claim that the price of a Section A ticket is $22.72. The price of a Section B ticket is $15.53. Okay, I'm going to put a prominent cloud around this major conclusion so that this jumps off the paper for anybody reading this solution. Okay, now that we have this, is it right? Okay, time to start assessing the correctness. For an application problem, you want two checks are probably best done. One, let's just check the math problem solution itself here, a math check. For that, do well to go back to the original equations and substitute our numbers. So substituting into the original equations. Alright, let's see here. For equation 1. Equation 1 has variables on both sides. So, well, it's fairly simple left-hand side, but LHS, the left-hand side equals x, and that is equal to, looking at our math answer, 22.72. Now, the right-hand side of this equation 1 is 1.35y plus 1.75. Alright, we'll see what that is using the calculator in just a moment. Let's prepare our other equation for substitution as well. Looking at the original equation 2, not equation 2a. Here's where you can even be sure that when you divided both sides by 5 and 10 or whatever, that you did this correctly using the original equation. Now equation 2 only has variables on one side. It has the constant on the other, so we just have to go ahead here and recompute 250x plus 600y and hope to get that 15,000 from that. Okay, time to go to the calculator. Here at the calculator, let's return to the home screen. Okay, the right-hand side of equation 1. We need 1.35y plus 1.75. 22.72, which is the left-hand side. Okay, that looks good. Now, the equation 2, check here. 250x plus 650y. Okay, great. That's the 15,000 we were looking for. Alright, let's record this on our paper. Our math check is looking good. So our calculated results here, the right hand side from this came out to be 22.72. That's our check there. We did this out, it came out to be 15,000, which is the right hand side of equation 2. That's a check. So at least the math problem looks well solved. Okay, let's go on to sensibility. Let's see, what about this? We got the prices of these two tickets figured out. What do we expect to see? Well, one thing, very plain and simple, is that the Section A tickets should cost more than Section B. Do they? Yes. Okay, so we have at least that much sensibility in order. What about the kind of general numbers we're talking here for these ticket prices? $23, $15, $16, these kind of things. Are these at all the kind of numbers that are sensible with the rest of this problem? Let's see if we can think of a really simple calculation that would give us something to gauge this whole math modeling by. For that, you might consider what if all the ticket prices were just to be the same? You were simply going to sell all the tickets at one price. Okay, so consider selling all. Now, how many tickets are there? There's going to be the 250 plus 600 equaling 850 tickets at the same price. What would this be? The price would equal, well, you take your $15,000 of receipt money, divide it by the 850, and see what you come up with. Just go to the calculator for a brief moment. Okay, 15,000 divided by 850. Okay, about 1765. Okay, so about 1765. And what do we expect of this one ticket price? Well, this should be intermediate between the Section A tickets and Section B tickets, because when those prices are created, we're having these expensive seats, and then the cheaper seats must sell at a below average price. And is this what we have going on? Yeah, yes it is. 22.72 more than this average price, 15.53 less than this average price. So this is kind of making sense with a very simple calculation. Let's complete our sentence here. So we said considering selling all tickets at the same price, the price is this. We expect this average price to be intermediate to Section A price and Section B price. This is indeed the case. Okay, so this now really feels pretty good. The kind of numbers we have here are kind of sensible with even a very simple crude calculation. So, looks good. Exercise 4. An investor receives $21,390 of total annual interest from two mutual funds. Fund A pays interest of 3.5% per annum. Fund B pays interest of 4.3% per annum. In order to have a comfortable level of risk, the investor maintains a ratio of 5 to 2, the amount invested in Fund A to the amount invested in Fund B. Determine the total investment made by the investor. Round to the nearest cent. Alright, in getting started here, the quantity asked for, the total investment made by the investor, would probably be a little bit clumsy to work with in translating information. So maybe we compute some other quantities and calculate the total investment after the fact. For instance, here maybe we let x equal the amount invested in Fund A, and let y equal the amount invested in Fund B. That will be dollars for units of measure, and y will equal the amount invested in Fund B, also in dollars. And we've got to remind ourselves that this is not actually what they're asking for in this question. We want the total investment, and so we could maybe here remind ourselves that the total investment will then equal x plus y. Make sure we compute this at the end of the question. Okay, getting started otherwise, what sort of information have we got here that might lead to an equation? Let's see here. We have this $21,390 of total annual interest from the two mutual funds. Okay, there's a source of the equation right there, I would suppose. So let's record this. Total annual interest income is $21,390. Okay, well, this total comes from two sources: the interest income from Fund A plus the interest income from Fund B. To compute the interest income from something, it's always principal times interest. In this case, x is the amount that's invested in A, and its interest is up here, 3.5% per annum. So multiply those two. That could be 0.035x. There's interest income from Fund A. Similarly, let's get the interest income from Fund B. Y is the principal invested in it. The interest rate is 4.3% in Fund B, so we need here 0.043y equaling 21390. Okay, this can be our equation 1. Got an equation. As far as manipulating this a little bit to make it look nicer, you might think about getting rid of the decimals here, but then you create such a huge number over here. Maybe just leave it alone. It's up to the solver what they want to do. Okay, let's move on. Look for more information that we need to account for. In order to have a comfortable level of risk, the investor maintains a 5 to 2 ratio. Amount in Fund A to amount in Fund B. Okay, so there's some information. the ratio of Fund A investment to Fund B investment is 5 to 2. Okay, well, let's form this ratio. How much invested to A to how much invested in B? X over Y equals, and then 5 to 2 can write as 5 halves. Alright, here's equation 2. Here, maybe to make this look a little nicer, equate cross multiples. 2x equals 5y, perhaps. Alright, equation 2a. Alright, let's see. Is there any more information in the problem we should account for? No, that looks about it. Okay, what kind of math problem have we got here? Looking at these two equations, okay, each equation is linear. There's two variables. So, observe that equations 1 and equation 2a constitute a linear system. Two variables. So let's take equation 1 and prepare it for calculator usage. This means we need to solve for y. Subtract 0.035x from both sides. Then divide both sides by 0.043. We could have y1 equaling 21390 minus 0.035x divided by 0.043. Okay. In the case of equation 2a, y is solved for pretty easily here. Just divide both sides by 5. Okay, we are ready to go to the calculator. Okay, here at the calculator, we can go to the y equals 2 edit screen. And for y1, we've got parenthesis 2, 1, 3, 9, 0 minus 0.035x parenthesis divided by 0.043. Okay, for y2 we have 2x divided by 5. Alright, now as far as getting the coordinate system set up here, maybe we could go to the window directly since it's an application problem. The x represents the amount invested in the fund A. Let's see, we don't know too much about that quantity to say what sort of numbers are possible, but we could start by at least getting some ballpark numbers up on the window for x. Now, since the investor did receive like more than $20,000 of annual interest income, let's just suppose that represented 1% of some investment. If it represented 1%, we could just take 20,000 times it by 100 and end up with about 2 million. Okay, now that should be a number larger than anything that x takes on, so maybe we start there for getting our window set up, have x go from 0 to 2 million, and see what happens. Okay, so for our window, x min 0 and x max. Let's see, one more 0. There's 2 million. Okay, and let the calculator worry about the y-axis by doing a zoom fit. Zoom 0 is zoom fit. Okay, we have got here this single point solution waiting for us to get. So let's go. Second, calculate intersect. I'll move a little closer before I start answering questions. Is that y1 the first curve? Yes. Is that our second curve y2? Yes, by pushing enter. For a guess, moving the calculator cursor over a little bit and enter. Okay, have these numbers here. I suppose it's time to go back to our paper and start recording things. Well, wait a minute. Let's remember that although we have an x and a y here, what we really need is the total investment to answer the question. Alright, so we actually need x plus y pretty much immediately to be answering our question. Alright, let's go back to the home screen for a minute. And in a question like this, although we will answer the question asked for, it's still not a bad idea to provide the other important information. So let's take a look at x here, just so we have it on the home screen. Let's take a look at y on the home screen. These are our claimed individual investments in Fund A and Fund B, respectively. Now, the quantity we actually need to answer the question is an x plus alpha y. Okay. Now, we're ready to go to our paper and start recording. Okay. So here we could write a sentence by looking at those numbers in the calculator. Now, those are amounts in dollars of investments in Fund A, Fund B, and the x plus y is the total investment. Alright, so we'll even go a little extra here and provide additional information in answering the question. We can say the amount invested in Fund A is $409,770.11. Get a dollar symbol there to get our units of measure. And our second sentence could say that ditto, the amount invested in Fund B is $163,908.05. Units of measure is dollars. Okay, now to actually answer the question. Thus, the total investment is $573,678.16. Okay. There's our prominent conclusion. Now, let's see here. What shall we do? We want to make sure this is correct. Okay, time for some checks. First, let's review the math problem solution. Okay, we could solve this by substituting x and y into the original equations. Alright, we look back at those original equations. Back at equation 1, the left-hand side had all of the variables in it, so we'll need to compute 0.035x plus 0.043y and see what we come up with there. Okay, the second equation, and I look at the original one, not even, it's equation 2, not equation 2a, because we don't want to chance some algebraic error getting overlooked here. That's why the original equations are always the ones to use. In the original equation, we need to compute x divided by y and see what that is. So here's equation 1. Here's equation 2. Okay, it's time to go to the calculator. Okay, here at the calculator, perhaps we clear the home screen and start with the first equation. That's 0.035x plus 0. You don't have to put the first 0 if you don't want to. 0.043 alpha y. Get a number. Okay, that's nice to see because that is the other side of the equation of equation 1. Now, the equation 2 check here. We're looking at x divided by y, 2.5, which is equal to 5/2, and that will give us a nice math check on the second equation. Okay, let's go back to the paper. Alright, so our calculator yielded a 21,390 here, which is indeed the right-hand side of equation 1. Check there. Here, calculator came up with 2.5, which is the very same as 5 divided by 2. There's our 5 to 2 ratio. That's a check. Okay, now, sensibility. The concern with a question like this can be in the orders of magnitude. Order of magnitude means the power of 10. In other words, if you have answers that are like 15, 16, 17, and the correct answers were 150, 160, 170, okay, then you are off by an order of magnitude, by a factor of 10. And that's the kind of thing that oftentimes gets confused in a real application problem, is that the translations cause completely erroneous answers off by orders of magnitude. So let's check that out here. Now we've got this total investment here of 573,000 and so on. Well, maybe it should be 57,000 and so on, or maybe it should be 5.7 million. Who knows? We could be way off here. So let's do something that gives us some feeling that this is in the right ballpark. And we try to do something really simple that's only requires a minor calculation for comparison. For instance, in this case, we have this investment income of the 21,000 plus, and it's obtained by getting these investments in this Fund A and Fund B that paid 3.5 and 4.3% respectively. Okay, just for a simple kind of ballpark calculation, 3.5, 4.3. Okay, let's just say 4%. What if we had an investment at 4% interest, and it was just a single investment, and it received $21,000 of interest income? Let's see what size investment that is, and that should be at least in the same order of magnitude as our calculation of this question here, because it's kind of a similar situation. So for sensibility here, we're saying to check the order of magnitude of the claimed total investment. Let's just do a we'll compute the principal needed at say 4% per annum to generate, we'll just say 21,000. Okay, we'll use the number $21,390 of interest. Okay, so what's the calculation involved here? Well, we have the idea that the interest income is equal to your principal times the interest rate so in this case the principal under these conditions should equal the interest income. We're talking about 21,390 divide by, say, about 4%, and see about what kind of number we get here. Quick calculator computation. So with the calculator, 21,390 divided by 0.04. Enter. Okay, so this is about 535,000. Back to the paper. So this turns out to be about, this is about equals to $535,000. And that's good to see, because we're in our detailed calculation of the specifics here, we had 573,000 plus or whatever, and so this is indeed has the same order of magnitude as our solution investment. Okay, so let's see here. How's our sentence going? We have computed this principal. Okay, and what we're glad to see here is which has the same order of magnitude as the claimed solution investment, which was about equal to 574,000. Okay, thus consistency. So this looks pretty good. Now it even feels good. Okay.